Our next presenter is Jeremiah Cox from Microsoft. I did want to let you know this presentation goes till noon, and then lunch will be served right out here, so we get a half an hour to eat. So we're trying to ask people to come in here and eat, and then the next presentation will start at 12:30 to 1, and that will be Brian. Thank you.
Okay, hello everyone. For the few of you who may not know me, I'm Jeremiah Cox, a program manager at Microsoft. Been working on UEFI for half a dozen-ish years. Started with UEFI Secure Boot, and sort of been working on trying to improve UEFI, especially security since then. Don't judge me based on that, please. All right. Okay, here's the agenda. It's your opportunity to leave if you don't like it, but I think it's pretty exciting. We're going to start by talking about DMA. It's a favorite topic, right? Hasn't caused any problems. And then I think a lot of folks today have talked about servicing and updating firmware. So we're going to talk about that. And then Project Mu, which is how we're doing that in a lot of our Microsoft products. Okay, kernel DMA protection. I didn't pick the name. It's gone by a code name DMA guard, and if you open Windows Defender, it'll call it memory access protection. I think we have too many marketing people. No, don't tell me when I said that. Too many code names. All right, so what are we trying to do here with this feature? The goal is to prevent or mitigate drive-by DMA attacks. So this is not the malicious USB-C projector display. This is you leave your mobile device for, say, 10 minutes, return to it. You would like some confidence that someone has not stolen your important data or injected a rootkit. That's the threat model here. And we're going to say maybe 10 minutes, no screwdrivers. Some people want to say one screw, but it just depends on who you talk to. You know, we have to draw a line somewhere. Now, it's called kernel DMA protection, but the reason was really because we have a feature that we shipped a few years ago that said that it protected DMA, but it only protected DMA for our virtualization-based security feature. It did not protect any other assets like the kernel. This one does. However, it needs support from UEFI in order to deliver this security promise. So that's work for you. We need to either block or the DMA capable ports or sandbox that DMA so that our friends can be protected. So we're doing the speed version of this based on this year's 30-minute slots. If you're an IHV and you have hardware that does DMA, you probably don't want to be turned off. You would prefer to function at boot time. You should enable sandboxing of the DMA in your driver. It's not a new protocol. It's not new functions. It's just that they actually do something now. PCI protocol, map on map, or allocate buffer. They're a step in the right direction. You still may need to do a little extra thinking in light of some recent security talks, but this will get you well under your way to protecting your customers from these drive-by DMA attacks. We have some documentation online. You'll actually find some more documentation, likely from your IHV related to your chipset configuration, IOMMU configuration, some of those things. So that's not the end of the documentation. We also have some tests. Now jumping ahead a little bit, these come from Project Mu. You're not going to just find these in the HLK because you can't hand them over to a vendor and just say run. Security tests tend to be a little harder. This is for your engineering team to try to audit, have I gotten closer to success with my implementation? And feel free to chat with us if you have some questions about that. So modern servicing. So much for that. What is modern servicing? Okay. So a long while back, Microsoft learned that software has bugs. It also has security bugs. And the cadence of Microsoft patches, running at a rate of, let's say, annual service pack releases, just wasn't keeping pace with the bad guys, right? And so we moved to a model where now we patch every Tuesday, sometimes more often. Regular cadence is, patch Tuesday, which is monthly. The idea of modern servicing is let's take this learning that we have in the Windows operating system and bring it to the other software, in particular the critical software that's in the system. I have some news. Firmware is software. Firmware has bugs. Firmware has security bugs. We'd like to bring you along on this journey. The idea here is let's endeavor to service faster, work together to have some reusable tools and infrastructure, stay ahead, or at least keep pace with the bad guys. And we're going to do that in a variety of ways. Part of what we're trying to do is enable our ecosystem, including firmware partners, to leverage some of the tools and processes that we've used for Windows for updating your firmware. We're going to reuse some existing specs like capsule update, ESRT. We have some existing infrastructure around Windows Update, driver packages, how to sign driver packages, things like that that we can reuse to help everyone move a little faster. Some of what Windows does is called flighting and telemetry to help us have more confidence. Do we hit the gas pedal or hit the brakes? This lets us move more quickly to protect our customers. I'll mention componentization so that we can service pieces, can help us move a bit faster. I think we've covered everything on this one. Okay, so drilling into firmware, we want to fix firmware security issues, protect everyone quickly, comprehensively, and reliably. Let's talk about each of these quickly. Good news, bad news at the same time. We have a benchmark. Project Zero has helped us out here by saying 90 days is how much time they will allocate to let you make your fixes before they tell everyone about problems. We may not like it, and for us in particular in the firmware hardware space, this is a bigger challenge, we feel, right? But it gives us something to aspire to achieve. Comprehensively, now there's several facets to this. One is let's make sure we have updates available for all makes and models. Everyone deserves to be protected from the bugs that have been shipped in our software. Also, it was mentioned earlier, we think posting a firmware update to the FTP site and calling it done, not really helping protect customers. Maybe a few enthusiasts, maybe some niche markets will pick that up, but we're not protecting customers that way. Proprietary update tools, maybe that you've provided to help your customers stay up to date. Our data suggests they're not as effective as they could be. So how do we really push to help everyone stay protected, right? Finally, on comprehensively, taking a little bit of a twist is if you see a particular type of bug, don't just go squash the bug. Start working on squashing the bug, but go look around. Is this a family or a class of bug? There's a chance someone copied and pasted the same pattern somewhere else. So look around and see if you can find the other similar bugs that may be in the software. I used to play whack-a-mole as a kid, really enjoyed it. Now these days I really just don't have time. I want to ship one update, get everyone protected, not have to reset 30 days later because my phone rings, it's project 0 again, that update, not so complete. So let's try to make them comprehensive. Finally, reliably, right? Part of what was mentioned earlier was that why do folks just post the updates to the FTP site? Maybe we don't have confidence that systems will continue booting, that there won't be some customer support requests or RMAs. We need to address that. Right? Find fault-tolerant, reliable ways to update the firmware. Also, this idea that you push to a broad range of customers, but quickly give feedback, and you can hit the brakes if something is detected before you have even more customer support requests. All right, so what is Project Mu? So for the most part, it's actually Tiano Core, just restructured to be optimized for modern servicing. Or at least that's our point of view. So we have an open source example of how Surface is doing modern servicing. It's not complete. This is really just the UEFI core portion of that end-to-end story. But if you don't know, we published it to GitHub 6 months ago under the same BSD license as Tiano Core. We'll dive deeper in a moment. And it's right there for everyone to come take a look, explore, give us some feedback. If you look at our recent pull requests, you'll actually see one of the componentization efforts with crypto, making that a component that can be built and potentially serviced independently. You could just keep it as a component in debug builds to help folks resist the temptation to perhaps reach in and tweak things, let that binary interface act as a barrier to changing something without sending it upstream. We'll talk more about that in a moment. I wanted to mention this is not limited to how we do modern servicing on Surface. There's actually other Microsoft platforms, Hyper-V in last year's release, as well as one of our recent IoT releases on NXP's IMX8 are also leveraging Project Mu. What are the principles of Project Mu? The guiding principle is really one tree shared by, identical code shared by all of the Mu products. So if someone feels that they need to change the core of UEFI to enable something on their product, instead of making that change in a fork and it never goes anywhere else, we're going to pull that up into a core that's shared by all the products, and then we're going to work to get that upstreamed into Tiano Core. That's both for our benefit, so that next time we take an integration from Tiano Core, we have less work to do, but we help, it benefits you because we've seen a need to put in the change to enable some product or feature. You may want that as well. Stay current. So this is related to one tree. Instead of having a fork for every product and then cherry picking for the rest of eternity, we actually pull forward all the products to a more recent release of Project Mu. Some folks may worry about this. You're introducing some risk in your product. You're moving, you're living at the edge. You might be introducing new bugs. We feel that we have increased confidence that bugs are being squashed. If you get a call that there's a security bug in something that's 5 years old, your developer team may not remember all the ins and outs of the code from way back then. Things have been refactored since then. And we've forgotten a few things. And you might think you're fixing the bug, but you're not. You're introducing a bug. That bug may not be in the same file, line number. There may be more instances of a similar class of bug. We're trading that with our developers have the current code fresh in their mind. All the patches are fresh. We feel more confident that we have all of the patches. Are there some new bugs? Probably. Are we going to mitigate the risk of the new bugs and regressions? We're going to do continuous testing, and then later we'll do some flighting. We'll talk more about that. But essentially, we're now tracking the quarterly Tiano Core releases. We rebase to each release. We then put the changes that we have not upstreamed on top of that release. And we now actually have half a dozen products already on 1903. This is internally, not shipped yet, but that was last month. And we have half a dozen products that are in our internal testing at this point, right? That was pretty fast. Good job, Brett. Thank you. So again, we endeavor to get those changes into the common core, not let the individual product forks make them, and then upstream those in a Tiano core. Hopefully that's going to be something that you find beneficial. We find some creative channels to do that sometimes. We like pull requests. We'd be happy to talk more about that offline. We all have different styles and ways of operating. That just happens to be the one that we prefer but aren't using today. See, we've talked about focusing on the one tree and not servicing forks. And finally, let's get into less is more. It's an easy one. We get rid of the code that we don't think you need to build a modern PC. We don't have to understand that code, think about that code, or service that code. Less attack surface. That's probably one of the easiest ways to improve your security, is just not having something there. You don't have to validate it. Helps us with our validation, right? Are you going to lose a few customers? Maybe, maybe not. Maybe that feature isn't really needed anymore. Maybe that security feature is fake security today. Why do we keep selling customers fake security? Certain, maybe drive encryption or lock mechanisms. Simply my opinion. Let's dive a little bit into a code example. So here's a Project Mu Surface laptop. May not be large enough for you to grok if you're in the back, but what we have here is in the project, everything highlighted in green comes from Tiano Core, broken into 3 pieces. Base core is our endeavor to find the core primitives that you need to build everything else in UEFI. Build sort of the minimum UEFI platform, if you will. We did not achieve success. We've just started down the path. You'll find MDE package and MDE module package. That's quite a beast to try to unravel. We invite you to take a look and give your thoughts and feedback on that. Mu Tiano Plus, the one in the middle here, is under common. That one happens to be the package is built on top of the base core that we feel are all that you need to build a modern PC. So you'll notice some things from Tiano Core are not present in Tiano Plus. We'll skip past Mu Plus to at the bottom in green under Silicon Intel, Mu Silicon Intel Tiano. Yeah, we're planning to rename that, don't worry. That happens to be the silicon code from Tiano Core, just in a different hierarchy. Again, sub-moduled in so that all of our different products can quickly and easily share that and reuse it. If you're wondering about light cyan, yeah, it's one of my favorite colors. Mu Plus happens to be some of the components that we've built over the years to support our products that are not in Tiano Core, that we've open sourced, again, under the BSD license, made available for you to come take, contribute back to. Examples include the on-screen keyboard, things that we need to build our BIOS menu or front page, some BIOS management things. Also our tests are all under Mu Plus. As far as the things that are not highlighted, that are not open source, you may be worried there's a lot of directories there, but they actually comprise a very small, relatively small percentage of the product makeup. MS Core internal is our staging branch for things we want to open source, but not quite there yet. Again, if you look at the hierarchy, you'll see that we're really trying to find all the common code and push it further up so that it can be reused by other folks and products. The ellipses actually are not in this project. They're here to make you think about other projects that may have common code under the silicon or platform folders. Validation. Okay. So as I mentioned, there's concern about being on this one tree, living on the edge, moving your products forward to new code, that you're going to introduce some regressions. So what do? We start with actually some check-in gates, something we think are helpful, some source analysis to enforce, hey, let's not copy and paste any GUIDs. There's an interesting one. Let's make sure maybe we're not checking in any credentials. Let's enforce certain characters, character sets aren't being checked in. The code looks good. What we can do from a quick static analysis point up front. And then the next one, I didn't capture it here, it's really new, is host-based unit testing. This actually, thank you Intel for sort of re-kicking off this idea. I think it'll be talked later by Brian. All right, he's going to talk about fuzzing. I'm just talking about it from a developer efficiency point of view. The idea is you can build and test quickly without having to build a platform and test within that full platform. You can just do it quickly within your OS. Very lightweight, very fast to iterate, be more efficient. We have some automated tests on a regular cadence of those builds, but some synthetic tests, but then you generally transition to platform tests just to get your coverage. We don't often sit around writing tests that don't support building a platform, and so it's often easier to get the coverage prior to this unit test framework by building a platform, booting it, running through your scenarios. And so what do? Obviously the dev tests his code before he checks it in, right? Yeah. Next step, we actually follow the modern servicing path of leveraging Windows Update to ship this build to some of our inner dev circles and get some coverage by having them use it for their day-to-day operations, right? Things they do, build, test, other things. Each person uses different features. I turn on all the security features, and that generally breaks something. My productivity sometimes is different. But this is very important before we go to the next wave, which is the Windows Update sending this firmware to the self-host group. What we've done there is we have a large group of folks at Microsoft who include upper-level managers who have these devices that we send our firmware to. If we break them, they're going to give us feedback for improvement that we're generally not looking for. So we try to do a really good job in that canary group of finding all the bugs so that they don't have to. And then if everything's looking good for a period of time across all these people inside Microsoft using the firmware build, we feel pretty good about it. We might declare that a particular release of Mu is in the stabilization phase. We can now take that if we want to have some sort of a patch to an in-market product, start going through some formal validation, right? Some stress, power, perf, some labs, things of that nature. If things look good, we'll get that signed. So now, if you have a system that maybe requires a signed firmware, it'll boot. Admittedly, on these earlier rings, we do have some devices that can either accept some sort of test signing so that you don't have devices that you have to cut a hole into and attach a DediProg. That's where you're living on the edge. But at that point, we move towards the Windows flight rings, where we can start sending to broader and broader audiences. Again, you start sending it out, getting feedback. Hopefully machines don't disappear, but if they do, you hit the brakes, figure out what's going on. And otherwise, your confidence just grows and grows Again, another nice thing is you're happening to have this identical code running across all your devices to also help boost your confidence. Someone did make a tweak over here, and you're going to break that. You're all sharing the same code. So that's what I had today. I thought with the time crunch and the way I normally speak, it would take too long. Here's a larger font size for the DMA-related points, and then with respect to like modern servicing and Project Mu, we'd really just invite you to come chat with us. It's a relatively deep and perhaps controversial topic, so it'd probably be easier just to come over to our table and engage with us. We'll be here today, tomorrow, and Thursday. We'll have folks here. You're not allowed. No, sorry, Gary. I was hoping you'd forget some before the end, Gary. All right, do we hold Gary for the last questions? No, I'm kidding. You can go ahead. You had your hand up first.
So Microsoft is now in the firmware business, and struggling with the idea of making a code base that is simultaneously development and production without branching. Welcome to the BIOS industry.
Just an example of how we're doing it, Gary.
No, but seriously, you're struggling with, now that you're doing firmware, you're struggling with the issues that all the people who do BIOS code bases have been struggling with for 30 years. But you mentioned, independent software updates when you were talking about modern servicing. And then you said you want to extend this modern servicing to the firmware layer. What granularity of firmware updates are you thinking of being independent? And as an OEM of Surface, are you okay with Intel updating their video BIOS separately from you?
So there's a two-part question there.
Always.
The first question is, how far do we go with componentization? I can tell you today we have the Intel ME as well as our EC as things that we can target independently with Windows Update and Service. If you watch our Project Mu repo, you'll see we're going to be releasing sort of a framework for a way that you could do that generically across any component that you choose. There are folks working in our repo who may be working on other components. You can see right now they're giving us feedback on our crypto component. I think it's a bit about OEM choice. If you're willing to do more validation on your own, if you want that control, if you're willing to do the testing and get it out in a timely fashion to protect everyone, more power to you. You have the control. Help us all have a safer world for all of our customers. You may be an OEM who's willing to relinquish some of that and have the confidence in the flighting system and maybe some of your IHVs where they can service those modules for you. You get to choose the granularity and you get to choose who you trust. That would be interesting. And then there's actually a bit of a middle ground that we're working on where perhaps your IHV could stage these things. I'm not committing to something here. Maybe they could stage something into Hardware Dev Center. Well, this is something that exists today for like video network storage, where maybe someone makes a particular brand of product and then OEMs might rebrand that product, right? There's a way that they can test and have that staged in Hardware Dev Center, and then an OEM can sort of click a button and then let that go through Windows Update.
I think that solving the granularization from the technical aspect sounds like it's well underway. I think it's the validation issue where if there's no chance to test the whole firmware stack as a whole before shipping it out, that's where OEMs get nervous and they end up getting support calls. And so there's still the validation issue to solve, but
and that's what I was trying to call out, where if we make it available to OEMs where you can say, use Windows Update and send it to 25 machines inside my company.
Right.
And then I get to test those machines. And then maybe the next button is send it to a broader audience. And then the next go button is, okay, Windows Insiders only, something like that. And we show you these machines came back, they have the update, they appear healthy, you know, that would provide the confidence
Yep.
to enable both the componentization and maybe also the let my IHV service it for me, because it'll be on them to hit the brake pedal if something, you know, goes wrong, if you relinquish that control to them. But we're still working through both the technical as well as the partnership aspects of
Right.
that.
Cool. Good. Thanks. I'll save my other painful questions for standing around in smaller environments. But
Happy hour, please.
yes.
All right. Thank you.